What's going on, my dudes? I'm Mr. Gardner, and this is Math Time with Mr. G. Today, we're just going to talk vocabulary with talking about data displays. So what types of graphs do we use, and when do we use them? So the first thing we're going to talk about is data sets. Data is what we collect, and the set is the list of numbers. So if I were to say how much money is in everyone's pocket right now, so one person might say $1, one person might say 0, one person may say 2, someone might say $100. So after interviewing all of these people, this is my data. Each bit that I ask is the data, but all together, that's my data set. Use this data sets to create what's called histograms. Those look like this, and we'll talk more about that in a little bit. And then we can do dot plots, which look something like this. And then we have box plots, which look something like this. Histograms are really good when we have categories. So if we were to talk about ages or money windows or years, okay? Histograms are really good for when we're looking at real broad information. Dot plots are really good for finding quick information. They're good to find what's called clusters. And a cluster is just a giant group of data that's all together. So if there's a gap, that's not part of the cluster. They're really good for finding outliers, and we'll talk a little bit what an outlier is. And then it's really good if we're going to add data, because if I go to my histogram and I add something, I have to erase this and redraw it. But if I have a dot plot, I just add it to it. And what's really useful for that is we can say, hey, is that new data part of the dot plot, or is it like way over here and has nothing to do with what we're talking about? And then our last one is box plots. And what they're really good for is the big five, comparing. So we're going to look at like two teachers and how they grade and do they grade fairly. So what do we want when we use a histogram? We're going to look for what's called normal. Let's use the example of grades you can get in class. So let's say all the way across. When I grade, I want most of my students to be in this range. And this is what's called normal. If it makes like a parabola shape around it, it's called normal. That means there's some on the end, but most people are in the middle. And histograms helps us find normal. It can also help us find what's called a skew. Bunch of people get A's. A couple people get B's. Very few get C's. One person got a D and no one gets an F. This isn't normal, it's skewed. And what skew means is there's nothing in this area. So this would be skewed left, because there's nothing over here. There's nothing on the left hand side. And just the opposite, if everyone failed or I did a horrible job teaching, that'd be skewed right, because the thing that histograms are really good at is finding what's called frequency. Frequency is just how many. Again, let's do our grades. I could really quickly see how many of each one. Dot plots. Okay, dot plots help us find mean, which is the average. Let's find the median, which is the middle. The mode, which is the most. That's stuff that doesn't fit. Range. And that's how far apart. So let's make, I asked everyone in the classroom to pull out how much money is in their pocket. And one person had $1. The mean would be, I would take all of this data, added together. So it'd be 5 plus 5 plus 5 plus 4 plus 3 plus 2 plus 2 plus 1. and then divided by how many x's there are. And the median is the middle number, so I would just go like, hey, that one, that one, that one. I'm just going from high to low, crossing things out. And I would say the median is 3.5 because there's these two right here, and I can't cross off both, so it's going to be just in the middle at 3.5. The mode is which one we saw the most. Well, we saw the most of 5. In our classroom, Bill Gates is here, and he has $1 million in his pocket. Well, that doesn't fit with the rest of us outside the norm. So it's real easy to see it because it's so far away from everything else. And then again, let's say that someone comes in and they just buy a car and they owe money and they have a bill in their pocket and they have negative $20,000. Well, that's also an outlier because we're all in the 1, 2, 3, 4, 5 range. Okay? And then range is how far apart. So let's remove Bill Gates and let's remove the guy who had the car. Our range is 5 and 1. So 5 minus 1. So our range would be 4. They're using box plots. And we're going to talk about the big 5. It helps us find the min. So let's say that we're going to look at people and money in their pockets again. This is what everyone's pocket. The minimum value would be 1. So it's real quick and easy. You just look at the bottom and say 1 is the smallest. It also helps us find the max, which is 5. Okay? Then it helps us find the median. And that's this line right here. So to find the median, I'm going to cross that out and just keep going back and forth until I find the very center number. Next, it helps me find my quartile 1. Quartile 1 means I go from my median, and I'm just going to cross back and forth until I find the middle. And since I have 2 in the middle, I divide this in half and get 2.5. And the last thing it helps us find is Q3. And again, I'm going to go from my median, and I'm going to go from top to bottom until I figure out which it is, and it's 4. What is skew and why is it useful? It helps us show if we're biased. We want some kind of normal where it has a natural up and natural down. So this would be normal. Skew, again, means where does it lack? So if I have a bunch here and it's slowly going down, my skew is to the right. If it is skewed to the right, we are going to say that the mean or the average is less than the median. And let's see if that makes sense. So let's say that there is 5 and 1. So that means that, let's say 5 people, money. Let's say 5 people have $1. So that means 1 plus 1 plus 1 plus 1 plus 1. So that means my average is going to be super, super small because of all these $1 bills, even though that there's 1, 2, 3, 4, 5. $5 bill is over here. There's only one of them. So my average is going to be way over here. So my mean is probably going to be 1-ish. However, if we're looking at this to find our median's still somewhere here at 3-ish. So if our mean is smaller than our median, we know it's skewed to the right. And then the opposite for skewed to the left. If my mean, which is all of this data over here, is greater than my median, because my median is in the middle, right here, then it's skewed to the left. Interquartile range, also known as IQR. IQR is Q3 minus Q1. And if we go back and look at our normal curve, most of our data is here. So we're going to say that this is all the data leading up to the first quarter. This is all of the data leading to the second quarter, also known as the median or the mean. And this is all the data to the third quarter. And then this is going to get to our max or our fourth quarter, but I put that in quotes as fourth quarter. So most of our data is right here between Q1 and Q3. So that helps us look at what are most students doing. So if I were to do grades, well, yeah, some people got an A and some people got an F, but what are most people getting? And that's what the IQR helps us find. Okay, the mean average deviation. This is also known as the MAD, the mean or the average. So I'm going to add all these up. So there's my total, 17. I'm going to divide that by how many pieces of data are in my data set, 1 by 7. So to find my average or my mean, I'm just going to take that number and divide it, and which is my mean. And then we're going to say how far away is most data from the mean. Well, I'm just going to do 2.4, and I'm always going to do absolute values. So it's going to be 1 minus 2.4, and I'm going to do that for each one. And remind ourselves that it's absolute valued, so we're always going to get a positive answer. It tells us what the mean average deviation is. How far are most of our numbers from being average? So 1 is 1.4 away from being average. 2 is really close to being average. 3 is really close to being average. And then 4, you're getting a little bit further away. And then 5 is super uncommon. So as closest to 0 is the most normal you are. So if you pull out of your pocket and say, hey, I have $2, we're going to say, hey, that's pretty normal. Most people, it's the standard deviation. Standard deviation is we are going to make our data normal. With standard deviation, we want to predict future data and see how unusual it is. So let's look at a normal curve. We are going to say that 68% of people in Mr. Gardner's class get somewhere between a C minus and a C plus. Then we're going to say, if we added a little bit more data, we're going to say that 97% of people get somewhere between a D minus and a B plus. And then if we look even further out, we're going to say that 99.7 people get an A to an F. Yeah, there are some that get F minuses, and yeah, there are some that get A pluses. But most people are in this curve of 68, 97, 99.7. If my median is somewhere in the middle, that means I have a normal curve. If my median is super close to an edge, and it doesn't matter which edge it is, we're going to say that's skewed. If it's normal, what we're going to do is we're going to take our range of max and min, we're going to subtract those and find our range. I'm going to divide it by 6. Well, why 6? We said so many people are in this range, so many people are in this range, so many people are in this range. This is my standard deviation. This is one set of normal. This is one set of normal. And these are going to be equally spaced out. So perfect set of people from C to B, B to A to A plus. These are also going to be the same. So there are 1, 2, 3, 4, 5, 6 spaces. There are 6 standard deviations from the middle. And that's where we get 6. If it's skewed, we have to say, hey, what's a different way to do it? Because they're not equally spaced out. They're all on one end. And if we do that, I'm going to take the IQR and I'm going to multiply it by 0.7. And the reason for that is 75% of our data is in this box plot. If it doesn't quite make sense right now, that's okay. Just watch the next videos. But if you do have questions, hit me up in the comments section. But be kind to each other, ask lots of questions, and think deeply.